Alright, here we're just comparing quadratic functions. The first function is given as an equation. The second one's already graphed for us. So let's just go ahead and put the first one in. We got x squared plus 4x. Now we can kind of compare the differences. Looks like we're comparing roots. Roots are x-intercepts. So the function we just graphed has an x-intercept of -4 and 0. And the function that's graphed over here on con is -3 and 4. Do they have the same roots? No, they don't have the same roots. Do they share one root?
Maybe.
No, they don't share a root. They have neither in common. None of the roots match up. Okay, again, let's go ahead and graph the function that's given to us so we can see what it looks like. And I'm going to go ahead and zoom out a little bit. We're talking about concavity here. Concavity refers to the direction the parabola opens. So the one that we graphed looks like it opens up. You can see that it's opening up. And the one that's graphed in con is opening down. So we can say that f is opening up and g is opening down. Here, let's go ahead and graph the function it gives us. 10x plus 1. And we're comparing y-intercepts. So the y-intercept of the function we graphed, f, is 1. Make sure I click on the right point. And the one that's graphed for us is 4. So clearly g has a bigger y-intercept. G has a greater y-intercept than f. And we have the last question here. Let's go ahead and graph it. Here it's asking us to compare the minimum. Which one has a greater minimum? Minimum refers, or maximum refers to the y value of the vertex. Let's find the one that we just graphed. So the minimum here is 4, and the minimum here is 2. 4 is greater than 2, so we can say that f has a greater minimum than g.